Everyone, in this video we're going to review the concepts of sequences, so particularly arithmetic and geometric sequences. So remember that a sequence is a list of numbers in a particular order, and because of that order, we can consider that it is a function with the domain of positive natural numbers. So the first term would have an input value of 1, second term would have an input value of 2, etc. In an arithmetic sequence, consecutive terms have a common difference. So what that means is if I subtract consecutive terms, so 10 minus 3, for example, or 17 minus 10, or 24 minus 17, in each case, if I get the same value, that is my common difference. So in this case, the common difference, which we denote with a D, is 7. The common difference can be negative, as is the case, for example, B. So 3 minus 5, for example, gives me the same thing as 1 minus 3, or negative 1 minus 1. In every case, I get negative 2. So that is the common difference in this example. There's two different ways of expressing in a formula an arithmetic sequence. The recursive formula depends on the term before, and it requires two parts. So for example, A, I have to say the first term. So the first term is 3. And then I give you the rule for getting a term from the previous term. So Tn is Tn minus 1 plus 7, because we take the previous term and we add 7. These two equations together give me define the sequence. For example, B, we have T1 is going to be equal to 5. And I'm going to define the recursive formula slightly differently. Instead of using n and n minus 1, I'm going to use n plus 1. So Tn plus 1 is Tn, which would be the previous term to that one, minus 2. So either one of these would be an acceptable recursive formula for these two examples. The general term is a little more useful in most cases, because what if I want to know the 100th term, but I don't necessarily need to know the 99 terms that come before? So the general term allows us to calculate a term from its position rather than from the previous term. And for this, we remember that an arithmetic sequence is essentially linear, where the common difference represents the slope of that line. So it's not quite the normal equation of a line, because the domain isn't all real numbers, it's just natural numbers. But the common difference is the slope, and the y-intercept would be the term before the first term. So there is no 0th term, so there is no y-intercept, but if there were, what would it be? So for the first example here, Tn is going to be 7 times n, because the slope times the variable. And then it would be minus 4, because if there were a term before the 3, it would have to be 3 minus 7, it would have to be minus 4. So for the second example, Tn is going to be equal to negative 2n, because the common difference is the slope. And if there were a term before the 5, it would have to be 7. So that would be the y-intercept of that line. So these are the general terms for arithmetic sequences. A geometric sequence is when our consecutive terms have a common ratio. In other words, if you divide them, you get the same thing. So negative 10 divided by 5 is the same as 20 divided by negative 10, which is the same as negative 40 divided by 20. In each case, we get negative 2. This is our common ratio, which we call R. It's not as immediately obvious in example B, but 5/3 divided by 2/3 is the same as 25/6 divided by 5/3, which is the same as 125/12 divided by 25/6. It becomes a little more obvious in like the 3rd, 4th, 5th, that each time what we're doing is we're multiplying the numerator by 5, and we're multiplying the denominator by 2. It's not quite as obvious in the previous cases, but if I divide consecutive terms, I do get a common ratio here of 5/2, so that is R. And like with arithmetic sequences, we can define geometric sequences either recursively or with a general term. So the recursive formula, again, requires me to define the first term. So in example A, the first term is 1, and then it tells me how I calculate a term from a preceding term. So in this case, Tn would be negative 2 times Tn minus 1. And both of those parts are necessary for a recursive definition. If I just have the second part, I don't know where to start the sequence, so it's not yet fully defined. And for B, T1 would be 2/3, and Tn plus 1 would be 5/2 times Tn. So there's the recursive formula. For the general term of a geometric sequence, we have exponential relationships. So for example A, we start with our first term. So Tn is, in this case, 5. The common ratio is going to be the base of the exponent because that's the thing we keep multiplying by. And the exponent is going to be n minus 1 because our first term hasn't yet been multiplied by -2, but every consecutive one. So for the second term, I've multiplied by -2 one time. For the third term, I've multiplied by -2 two times. So always one less than the term number. And in the second example, again, we start with our first term, which is 2/3. The common ratio is the base of the exponent, and the exponent is n minus 1. And those are the general terms for these geometric sequences.